whenever we are factoring, the first thing we always look for is a greatest common factor. So, Presley, for example 7, do we have a greatest common factor? What is it? Okay. 2. How about x's? 2 with an x squared behind it. Make sure you're always taking the lowest number of x's. Some students were not doing that correctly during second period. So we got 2x squared, and we're just dividing here, so that'll leave me with 1x squared plus 8x minus 9. Okay, so we need to factor our x squared plus 8x minus 9 further. So we're looking at our first term. It is an x squared. To get an x squared, we're just going to put an x and an x in those first spots. That last term is a negative 9. And so we need to get a number that we multiply to get negative 9, but we add or subtract to get a positive 8. Right? If you do the x method, that's what it looks like for that. So what do we multiply to get negative 9? Negative 1 and 9. Negative 3 and 3. Or we could switch the signs on that first one, 1 and negative 9. Okay? Do I have one of these that adds together to be 8? Yes, first one, right? Negative 1 and 9 is going to add together to give me 8, so I'm going to put a minus 1, a plus 9 here. We cannot use positive 1 and negative 9 because that would give us a negative 8 right there in the middle, and we got to have the sign match also. Okay, and that is going to be your answer. Remember that we can check these by graphing them. So if I go over here and type in my original, and my factored form, I have the same graph, so that lets me know that I did it correctly. Especially, we're going to do some delta math today, so especially on delta math, if you do that, that'll make sure you get it right before you type it in, and if you don't, you can ask questions before you do that. All right, let's look at example 3. Peyton, what's my greatest common, I'm not, 3. Example 8.
3.
Yeah. 3. How many x's can I take out, Peyton?
3.
Nope.
No.
It's your lowest exponent. This over here just has 1, so we are going to take the lowest exponent. Because when you're taking that out, it's like you got 3 x's here, you're taking 1 away. Right here, the most x's you can take away is 1 because you only have 1 right there. So that 3x is going to come out front, and then we'll get x squared. 21 divided by 3 is going to give us 7x, and we will get 12 there. Notice all my exponents just decreased by 1. Okay, we want to factor this further. So we will have our set of 2 parentheses. We'll have an x and an x. We need to multiply to get 12, but add or subtract to get negative 7, right? So if I think of numbers I can multiply to get a positive 12, I could use a positive 3 and a positive 4, a 2 and a 6, or a 1 and a 12. But do I really want to use positive numbers for this one? I do not, because I've got a minus 7 right here in the middle. So really I want negative 3 and negative 4, or negative 2 and negative 6, or negative 1 and negative 12. Which one of those will give us negative 7 if we add them together?
3 and 4.
3 and 4. So we're going to do minus 3, minus 4. And we could go type it into Desmos to double check if we needed to. I'd really suggest doing that when we get to like quiz or test time. Right now, you can take my word for it, that is correct. Okay. For number 9, we're looking for a greatest common factor there. Rhett, what would my greatest common factor be? One is the only number I could take out, but 1 won't really do anything. How about variables? How many x's could I take out? 2. So we can divide by x squared right here. So we've got x squared, and then we'll have x squared minus 4. And so it almost feels like you're done on this one because you got that, just 2 things in that parentheses. But this is one of the special ones where our middle terms are missing, right? So for this, I know I'm going to need an x and an x. This minus 4, there's 2 things I could use. I could use a -1 and a 4, or a -2 and a 2. But for these special cases, which ones do we want to use? If we want the middle terms to cancel out completely. -2 and 2. So we want to pick the ones that match, just have different signs. Yes, whenever you're missing that middle term, you should use the one that's going to be like the negative and the positive of that. And you're going to see several of those on your assignment today too. All right, 10 is one of the difficult ones because for 10, is there a greatest common factor on that one? There is not. So that means that I've got 2 sets of parentheses, and my first term is 12x squared, which has lots of options. I could do 3x times 4x. I could do 2x times 6x, or I could do 1x times 12x. And then for my last term, I've got -14. So I could do -1 and 14. I could do +1 and -14. I could do 2 and -7. I could do -2, +7. So this one's going to be kind of difficult because you have so many different options of things to check. I would start with the ones closer together, the 3x and the 4x, or maybe the 2x and 6x. I would usually not start by the x and the 12x, just because they don't seem to give those as problems as often. Plus, if you end up with the 12x, a lot of times you get like a really big number in the middle, and I don't see that happening here. So, I'm going to try 3x and 4x. Okay. And I'm going to try 2 and 7. So I'm going to do +2 minus 7. The numbers closest together just seem to work more often. They don't always work, but seem to work more often. So if I check this, that gives me 12x squared. That's good. I got minus 21x. I've got plus 8x. And I've got minus 14. So this would be 12x squared minus 13x minus 14. Is that what I'm looking for? It is not. But, is it close? It's really close because I just want a positive 13 instead of that negative 13. So this is an easy fix. What do I do to switch this so it'll be positive instead of negative?
So -2, +7?
-2 and a +7. So we'll just change this over here to a -2 and a +7. And so then when I multiply back, 3x times 4x is 12x squared. 3x times 7x is positive 21. This will give me a negative 8. That gives me the positive 13 in the middle. So we'll have 3x minus 2 and 4x plus 7. Okay, questions there? My X method, people, let's go back and I want to use X method on that just so you see how that is done. If you like to use X method, because it works just fine. If you don't want to learn anything about X method, just ignore me for this next couple minutes. I'm going to go back and do the same problem. Because X method is different when you have a number in front of this. So if I'm using X method, the number that goes right here is going to be 12 times negative 14. So let's grab the calculator to make this a little bit faster for us. 12 times negative 14 is going to be negative 168. And then we put our 13 right here is what we need. So we need the numbers that multiply to give us negative 168. And then divide, or add or subtract to give us 13. Now, negative 168, that's not very easy, right? I know it's even, so 2 and negative 84 works. I bet 4 will go into it. 4 and negative 42. Wonder if 6 goes into it. Yeah. 6 and negative 28. Negative 68 divided by 8. 8 and negative 21. There's the one that I need right there, because 8 plus, well, almost the one I need. 8 plus negative 21 would give me negative 13. So I would want to do negative 8 times positive 21. So I would put a negative 8 right here. I would put a positive 21 right here. I would have to divide both of those by 12. And I would reduce. So this one over here would give me, I could divide both of those by 4. I'll get negative 2/3. X goes in the bottom. Over here, I get, oh gosh, what's that going to be? 7 over 3. If I divide top, no, 7 over 4. Divide top and bottom. X goes in the bottom, so I get 3x minus 2, 4x plus 7, which is the same thing we got the other way. It's a trade-off. You don't have to guess and check whenever you do X method, but you also with X method sometimes end up with numbers like 168, which is not easy to break down, right? So if you like it, feel free to use it there. All right, questions? All right, I want you guys to try the next 4 on your own. So try those right there on your own. Okay. All right, I'm going to work these out real quick so you can see what we've got here. So here is your answer for the first one. The 3x squared here. So whenever you're doing your greatest common factor, you're just dividing. So 12 divided, that whatever number you can divide by, you're pulling it out here. So 12 divided by 4 is 3. And then you had 3 x's. This is just 1x, so you took 1 away, and that just gives you 2 x's right there. And then here, 20 divided by 4 gives you the 5. 8 divided by 4 gives you that 2. Okay. All right, questions on 11? If you like X method, when you get to this point right here, you'll do 3 times negative 2. That gives you negative 6. you're trying to get a 5 right here. This is what you add to. This is what you multiply to. So negative 6, you can do 1 and negative 6, 2 and 3, one of those negative. You could do negative 1, positive 6. You could do positive 2, negative 3. Though one of those that will give you a 5 is negative 1 and 6, but then you have to divide by the number in front of your x squared. So you got to divide by 3. 6 over 3 reduces to 2 over 1. X's go with what's in the bottom. So you end up with 3x minus 1. 3x minus 1 here. And then x plus 2. X plus 2 here. This one, the X method. X method can be used on any of them. It is more helpful whenever you have like a number in front of that x squared. Because if I do X method, like for example, this one right here, 3x is your greatest common factor. So we'll have a 3x out front. We'll have x squared plus 6x plus 9. So if I do X method on this one, and first of all, I'm only looking at just like this part right here to factor when I'm doing X method. Right here, I was just looking at this part. Whatever's your greatest common factor just kind of sits out front. You don't mess with it. So to get the number up here, I multiply this first number by the last number. So that's just going to give me a 9. And that's what I'm trying to multiply to get. And then the middle number goes right here. That's what I'm trying to add to get. But with this one, it's not really a lot different, whichever way you're thinking of it, because 1 times 9 just gives you 9 right here. So either way, you're trying to think about what you can multiply to get 9. And that would be 1 and 9, or 3 and 3. You could use negatives, but you don't want to on this one because everything's positive. So to get a 6, you're going to use 3 and 3. So you do a 3 here, 3 here. You would divide by the number up front, which is a 1. X's go in the bottom. I hate it. I don't like it.
That's what we're doing. Right now.
In 4? No, 3 honors?
Oh, yeah, we should
Yeah.
do it. That's what we have to do.
Yeah.
That's good stuff.
I don't like it.
I'll send some else to stuff here.
We might could use it here in a minute.
Right.
We might could use it here in a minute.
I think I did. Did I do it that way with you, David? Can't remember.
Yeah.
I don't think how long I have been doing it. You don't
It's
like-
really not any like if you don't have a number in front, it's the same. It's the same. It's the same as the way I'm doing it. You're just drawing the x for it. But if you got a coefficient, it's different. I think it's a trick, and you don't really know what you're doing, and you can't remember it. But
And I like it just too, because if they put X's on the paper, see when you grade your paper, you put X's on it, they don't feel so bad.
right,
They put some and you put some.
right. Coach was so good at explaining things away like that. All right. Okay, so this is what you should get for 2. Now, you're going to see several like number 13 on the Delta Math that we're going to do today. Okay, first thing, we always look for greatest common factor. It is 5x for this one. So we'll have the 5x out front. We'll have 9x to the 4th minus 16. Okay, now, this only has 2 terms. So it's one of those weird ones where our middle term is missing. Okay, I definitely would not use X method for this, because if you do, you got to do 9 times negative 16, and then you got to find factors of whatever that is, and it gets really bad. If you think of it like this, though, we need a number that will multiply to give us 9x to the 4th. If the middle term is missing, Like I could do 3x squared times 3x squared. That exponent, if it's higher than 2, you're just splitting it. So it's like 4, if you have 4 x's, you're putting 2 here and 2 here. If that was 10, we'd put x to the 5th and x to the 5th. The other option is 1x squared times 9x squared. Don't use that one. Because if those middle terms canceled out, it means that what you had matched, and the only difference you had was the middle term. So use the ones that are the same. Use 3x squared and 3x squared. And then same thing for the negative 16. You could multiply negative 1 times 16, or you could do negative 4 and 4, or you could do negative 2 and 8, or we could switch the signs on those, right? But if this is one where the middle terms canceled out, use the two that would cancel each other out. Negative 4, positive 4 for that. And so that would be your answer there. And if you multiply it back or check it in Desmos, that's going to work. Okay, questions on that one? Okay. Let's look at 14. What is my greatest common factor on 14? 2. It's about everything by 2. So I got 2. I've got 2x squared plus 3x minus 9. So remember, we're not really paying attention to this 2 out front. We're only looking at this middle part right here to break it down. I have got my first term is 2x squared. That is 2x times x. My last term is negative 9. I could do negative 9 times 1. I could do negative 3 times 3. I could do positive 9 times negative 1. So, I know my only option for my x's is just to do 2x and x. The numbers here, none of those adds will give me 3 because this is the more complicated problem, right? We've kind of got to guess and check on this. So, I usually try the ones that are closer together first. They don't always work, but a lot of times they will. So if I do like a positive 3 and a negative 3 here, if I check it, if I multiply it back, I got 2x squared minus 6x plus 3x minus 9. When I put those together, I get a negative 3x. Is that what I want to get? It's not, but it's close, right? So if I just switch my signs here and make this first one a negative and the second one a positive, then when I multiply it back, this will be a positive 6 and that'll be a negative 3, and that will give me the positive 3 that I want. You can also check by typing them into Desmos and see if they work. So that would be my answer there. If you want to X method that one, X method's not so bad on that one. 2 times negative 8 is negative 18. Right here we're trying to get 3 in the middle. So for negative 18, I could do 1 times negative 18. I could do 2 times negative 9. I could do 3 times negative 6. And the one of those that gives you 3 is your 3 and your negative 6. So you would do 3, you do negative 6, you would divide by the number out front. This reduces to negative 3 over 1. X's go on the bottom. So you would have 2x plus, oh, I got the signs wrong. That's positive, that's negative. 2x minus 3, and then we got x plus 3 there as well. All right, questions? Second period was pretty rusty on this. I think we probably just need to get into trying some on our own and see how we're doing. So we are going to do a delta math here. So if you guys will go to delta math, there is one type I want to show you real quick. Let me see if I can find a problem like it. Make you cry. Trying to make you factor. I think I might cry about it too. Second period was not working very hard today for me. Let's see if I can find one of these problems I want you guys to do. Okay, here's one. You might run into something like this. 81 minus x to the 8th. There is not a greatest common factor for that one, right? There's also not a middle term, so that middle term has disappeared. So when I factor this, I'm looking at that first term, which is 81, and I'm looking for something I can multiply to get 81. I could do 1 and 81. The one I really want to use is 9 and 9, right, because the middle term's missing. There's some other stuff we could do, like 3 and 27. There might be some more. Might not be. But 9 and 9 is what we want to use there. To get x to the 8th, you're just splitting those 8 x's apart. It would be x to the 4th times x to the 4th. So you would use, and one of them is negative, so one of them needs to be negative. So you can do minus x to the 4th and plus x to the 4th. But what you will find on this one is you're not done. If you type it in, you will get it wrong. You will if you graph it on Desmos, it'll look like you're correct. And you have factored correctly, you just haven't factored completely. There's more that can be done. Because we can do the same thing again with the first expression. Not the second, because you got a plus sign right there. You can't do the special rule if you got the second, the plus sign. So, what number could I multiply together to get 9? 3 and 3. What could I multiply together to get x to the 4th? X to the 2nd times x to the 2nd. We want to make one of them positive, one of them negative. The second one right here, the 9 plus x to the 4th, it will not break down like that because you don't have a minus sign right there. It's not a difference of squares. So you may run into some of these where they will factor more than once. For some reason they factored out a negative. You don't have to do that here. It should accept that. We won't have any trouble with that during the second period. So for Delta Math, you are welcome to work with anyone that you would like. You're also welcome to use whiteboards if you would like for those. So go ahead and get started. I will be around to help you guys.